Hi, this is Mr. Kier. In this video, we're going to be looking at balancing more complex chemical equations. So let's start out with the relatively easy one. So what I have here is something called the Haber process. And what this is the way that we produce fertilizer in much of the industrialized world. So what we have is we've got nitrogen over here, nitrogen gas, and it combines with hydrogen gas to produce ammonia. And ammonia is what we use as fertilizer. It's also a gas. And what we want to do is we want to balance this chemical equation. So let's take a look at what we have before and after. So I'm going to have my nitrogen and hydrogen before and after. That's what we have before. So before I'm going to have two nitrogens, two hydrogens. Afterwards, I've got one and three. So there's obviously imbalance. I'm going to start off with the nitrogen. So I'm going to have two of these ammonia molecules. I'll put a coefficient in front here. So it's going to make or give me two nitrogen atoms. However, we're also going to have now 2 times 3 or 6 hydrogen atoms. So what we want to do now is we're okay with the nitrogens, but my hydrogens are off. So what I can do is go back here and I have 6 hydrogens. So I just put a 3 in front here and a coefficient here, so which gives me 3 times 2 or 6 hydrogens. And then that's it. So then we are balanced. So the chemical equation for the Haber process would be this. So we have one nitrogen molecule combining with 3 hydrogen molecules, and they produce 2 ammonia molecules. All right, let's look at another one here. So this is another one that we have here. So magnesium hydroxide combined with ammonium chloride, producing ammonia gas, water, magnesium chloride. Oh, it looks like a lot. So let's start by keeping track of all the different elements we have here. So we've got a magnesium on both sides. Okay, so we got magnesium. Just going to check it off. We have hydroxide. Oh, we don't have hydroxide here, so I have to break it apart into the oxygen and the hydrogen. And then I have a ammonia, but I have ammonia here, not the same. So I have to break this apart into nitrogen, hydrogen, and I have a chlorine. So this is what it looks like for the elements I have to take care of, I have to take into account. So let's go through this. I've got one magnesium, two oxygens here, two hydrogens, but I also have four here, which gives me 6 hydrogens in total. I have a nitrogen and one chlorine. Let's look at this side now. So on this side, I'm going to have one nitrogen. Oxygen looks like I've got one. Here I've got 3, 4, 5 hydrogens, one nitrogen, and it looks like we've got 2 chlorines over here. So it looks like a lot of things happening. Well, we'll start off bit by bit. So let's look at maybe the, I don't know, looks like the chlorines. Maybe the chlorines, doesn't really matter where we start here. Um, so what I want to do is I want to make sure the chlorines are even on both sides. So I've got 2 chlorines. I only have 1 here. So let's put a coefficient in front. Use a different color. So I'll make this 2. So when I do that, I'm going to get my 2 chlorines. So I'm okay there. But I've changed my nitrogens. Now I'm going to have 2 nitrogens. And I'm going to have 8, 9, 10 of these hydrogens. And so we've made some things better, some things worse. That's okay. Let's look at the next thing that we can do. So what the next thing I can do is perhaps even out the oxygens here. So here I've got 2 oxygens. Here I only have 1, so I can put maybe a 2 in front of here. So it's going to give me 2 oxygens, so we're balanced there. But I've changed the number of hydrogens here. So I'm going to have 4, 5, 6, 7 hydrogens. I have 7 hydrogens. Well, getting better, but still not quite there. So far it looks like that we got the nitrogens off and the hydrogens that are off. So let's see what we can do. Well, it looks like I got 2 nitrogens here, so only 1 here. So put a coefficient of 2 in front. So what that means is I'm going to have 2 nitrogens, so that's okay. And I'm going to have 2 times 3, so 6. But remember, we also have 7, 8, 9, 10. We have extra hydrogens here, so we have 10 hydrogens there. And looks like we're balanced. Let's double check. 1 magnesium, 2 oxygens, okay? And I have 2 and then 8, so 10 hydrogens. And we have here 6 and 4, so 10 hydrogens. two nitrogens, and finally two chlorines and two chlorines. Great, we're balanced. So we balanced the chemical equation here. Okay. All right, off to the next one. The next one involves this: ammonia and water combining to produce water and nitrogen. So let's do the same thing we did before. Let's list all the elements we have here. So you have nitrogen, hydrogen, and oxygen on both sides. Okay, this looks like it's going to be a little bit easier. Let's find out. And we'll tally up everything that we have. So what do we have here? We've got one nitrogen, three hydrogens, two oxygens. We've got two hydrogens, one oxygen, and two nitrogens. Okay, so where do we start? I'm going to try to maybe leave the nitrogen oxygen for the end if possible, because if we change them, I don't change any other elements. So let's take a look at the nitrogen, maybe the ammonia here. So it looks like I've got ammonia is one. Here I got two. Let's change this. I'm going to have two in front of here. So I have two ammonias. So this will become a two. And then the hydrogens are going to have six and two oxygens. So we're okay with the nitrogens, but now I'm off with the hydrogens. Let's see what we can do on this side. So here, what do I have? I've got six hydrogens. Here I only have two. Okay, what if I put a three in front of here? So that'll give me my six hydrogens. And now I'm going to have three oxygens, which is good. So what do we have so far? Looks like everything is okay but the oxygens. And it's really funny. I've got this odd number here. I've got three and here I have two. So somehow, if you think about it, I can only have multiples of two here. 2, 4, 6, 8. Here, if I have to make this into some kind of even number, the only way to do that would be maybe to multiply this by 2. So we're going to have 6 oxygens. So let's try that out. So let's change this to 6. So now we're going to have, actually no, yeah, we're going to have 6 oxygens. There we go. And what do I have now? Well, I got 12 of these hydrogens, which has messed me up a little bit. So I'm going to go back on this side. I'm going to try to fix the oxygen. So remember we had 6. Let's make this into a 6. It's very easy to do. Put a 3 in front. And then with my 6 oxygens, looks like we're okay. And now I need to have more hydrogens. I need to have 12. So in front of here to get 12, I'm going to multiply this by 4. So let's see what happens now. So we have 4 nitrogens, 12 hydrogens. Looks like the hydrogens are going to be okay. Oxygens are okay. And it's only the nitrogens that are off. So let's see, we've got 4. And to make this into a 4, I put 2 in there, 4, and we're all balanced. So this is the chemical equation over here. So sometimes you might have to go back and forth a few times until you get things evened out. The one thing I want to double check to see if I can divide any of these by 2. I could do that here, 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 but I can't do that here, so I can't reduce to lowest terms. This is it. And that's it. So when you're working on the examples on your workbook, just keep in mind some of them are very easy. If they're more complex, take your time. You might have to go back and forth. Eventually, you will balance them. Okay? Anyway, have fun with the balancing. This is Mr. Cure. Take care.